This video is going to be about using diagrams to solve quadratic equations. The diagram we're going to use is a square with a small square taken out of the bottom left-hand corner, and we're going to take that shaded area and we're going to transform it into a rectangle, and the dimensions of the rectangle will be used to find the solutions to the quadratic. So the first step in this is to multiply the a by the c. So 5 times 8, which is 40. And that's going to be the area of the shaded region. Next thing we're going to do is divide the b by 2. So 14 divided by 2 is 7. And that's going to be the lengths of the larger square in this case. Now we can see, of course, that 7 times 7 is 49 is the area of the bigger square, and if we already know that the shaded one is 40, that obviously means that the smaller square is 9. If we square root that to find the lengths of the sides of the smaller square, it's going to be 3. So now what we're going to do is take that shaded area and turn it into a rectangle. The easiest way to do that is to take the purple rectangle and put it onto the side as shown in the diagram here. Now the dimensions of this rectangle, clearly the height of the red rectangle is just 7 take away 3, and the width is 7 plus 3. So what we have is a rectangle which has dimensions 4 and 10. What we're going to do next is we're going to reduce the size of that by dividing both those numbers by 5, which is the value of a, the number of x squareds. The final thing we need to do is to work out the sign of the solutions. We can do that because we know that the c is positive, so we know that both signs are the same. And because the b is positive, we know that both of those signs will actually be negative. So my solutions to this equation are minus 4/5 and minus 2. Let's look at another example, which the numbers don't come out to be so nice, but let's use the same method and see how it works. So first step, of course, 2 times 3 is 6. That's the area of the shaded region. We're going to divide the b by 2. We're going to ignore the negative sign because we can't have lengths which are negative. So it's going to have a 5 by 5 square. Now clearly 5 times 5 is 25. We have the 6 there. So that means that the area of the smaller, well, it's not actually smaller in this case, but it's just a demonstration. So that's going to be an area of 19. So clearly the length of each of the sides that gives you an area of 19 will be square root of 19. Again, we're going to transform the shaded area into a rectangle, and I think it's pretty clear that, again, the height of the red rectangle is 5 minus root 19, and the width of the shape is going to be 5 plus root 19. Then we're going to divide it by 2, which is the value of a. And then we're going to think about the signs. Well, actually in this case, because we have a positive c, we know the signs are the same. And because b is negative, we know that both of the roots will be both positive. So we don't need to do anything in this case. Because both of the lengths are positive, obviously. So those are my two solutions, and that's the decimal equivalent. Okay, third question. This one, there's a slightly different method in this case. It's just a slight change, but let's go through it. So follow the same steps as before. We're going to do 1 times minus 12. Now you can see we have a problem here because obviously we cannot have an area of minus 12. So we're going to make it positive 12, but this time when we divide b by 2, 6 divided by 2 is 3, that's going to be the lengths of the smaller square. Otherwise, you'll end up with negative values and it's not going to work out. So this time it's the smaller square that has the length, whereas before, when a times c was positive, we had the larger square having that dimensions. So anyway, carry on as normal. So obviously 3 times 3 is 9. Now 9 plus 12 obviously gives you 21. So if we square root to find the lengths of the larger square, we get obviously square root of 21. Carry on again. We're going to transform the shape into a rectangle, and hopefully it's clear now that it's going to be root 21 minus 3 is the height and root 21 plus 3 is the length. Okay, so there's my results. Again, we're going to check the signs. Now this time the c is negative, so we know that the signs of the two answers are going to be different, and we can use the sign of b, which in this case is positive, to tell us that the smaller one will be positive, so that the other one must be negative. So those are my solutions, and then these are the decimal equivalents. Okay, fourth question. Now obviously the questions I did before, I made it nicer because we had an even value for b. So here we have a odd value. Okay, let's go through the steps. So 5 times minus 6 is minus 30. So we put the 30 as the shaded area, but because it's a negative, we're going to use the smaller square. So 13 divided by 2 is going to be the dimensions of the smaller square. Now 13 over 2 times 13 over 2, that gives me an area of 169 over 4. Add that to the 30. That's 289 divided by 4, and obviously I need to square root that to find the lengths and width of the bigger square. So that's going to be 17 over 2. Again, transforming this into a rectangle. Well, 17 over 2 minus 13 over 2 is 4 over 2, which is 2. And the width is going to be 17 over 2 plus 13 over 2, which is actually 15. So I've got 2 and 15. Again, I'm going to divide them by the a, so 2/5 and 15 divided by 5. Now, because the value of c is negative, means that we know that they both have different signs, and because b is negative, we know that the smallest value, which is obviously the one on the left, has to be negative and the other one has to be positive. So my final solutions are minus 2/5 and 3.